Okay, so we're going to be looking at the intermediate value theorem. And like all value theorems, they can be broken down into two parts. The first word, and then value theorem, so intermediate and value theorem. So it's a theorem about a value, and it's the intermediate one that we're looking at this time. Intermediate means between, so we're going to look at values in between certain things, and there's a theorem with values that are in between two things. So I have exactly that. A function defined between two things a to b, and let's say it is defined a to b, so I guess defined, and it's a function that basically has a property of being continuous. It's a continuous function. Okay, and then we can also say this is f of a, and this is f of b. Okay, so what does the intermediate value theorem says if we're thinking about in between? It says that, let me zoom out here. It says that if these two conditions are basically satisfied, where it's defined on this closed interval a to b and it's a continuous function on this closed interval, the function takes on every value between f of a and f of b. If f of x is continuous on an interval a to b. Very simple definition. This is what the intermediate value theorem is. So what does that actually mean? A function takes on every value between f of a and f of b if f of x is continuous on this interval. If I were to pick any number between f of a and f of b, for example 0, the intermediate value theorem guarantees that there's going to be a point where f of some number is 0, which is right here. It will take on every value between these two things, so it can take slightly below, and every value along this curve is going to be in between here. It's going to take on every single value between those two things. Notice that it doesn't really say anything about what happens if it goes above, because it's not necessarily saying that. It's saying between these two values there's guaranteed to be a defined point there. Typically with intermediate value theorem, we actually want to show that something crosses the 0. In other words, so this is kind of like something we typically want to find. If a continuous function is positive, then becomes negative, it must cross 0, because it has to take on every single value between it. So every positive value to negative value, somewhere in between there's something 0. It must cross 0. So this is the idea of the intermediate value theorem. Let's actually see what happens when we break the definition. If we kind of make the interval not specifically correct, or make the continuous function not continuous anymore. See how it breaks down, how the definition just breaks down. I guess the most obvious continuous or discontinuous function is something that's defined like this. And let's say the endpoint's here and here. That means f of a is here and f of b is up here. Notice that because it's not continuous at every value, or not a continuous function within this interval, there's a discontinuity here, it's not going to take on this value, which is between f of a and f of b. Notice that is not defined here. That means since it's not continuous, we can't use the intermediate value theorem, so the IVT breaks down. And that's basically most of how it breaks down. If there's a discontinuity somewhere in that interval, it won't work. However, if I actually define the interval to be here, it doesn't matter that the left side, all the stuff on the left, is discontinuous. We're only looking at specifically here and here. Since it's continuous along A to B, we can use the IVT. But if I were to define A to be on this far left right here, there's a discontinuity between A and B, so it breaks down and we can't use the intermediate value theorem. And what does that mean with derivatives? Okay, so the IVT for derivatives, what does that mean? If A and B are 2 points in an interval on which f is differentiable, then the derivative of prime takes on every value between the derivative at A and the derivative at B. And this one, we're taking it a step further. We have one that's for regular graphs, but now we have one for derivatives. What does that mean? Let's look at this graph. Let's say this is f of x. Basically what I can say is that if I define A and B here, the slope here, this slope, and this slope here, that's the slope at A and B, the derivatives must be every single value between this slope value and this slope value. So a positive slope value and a negative slope value. And again, we're typically looking for 0. And since it's continuous and this is like a continuous function and differentiable function, we can guarantee that there's going to be every single point between this slope, we can say this is like 10, and this slope, which is like negative 12. So it's going to be past 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way to the negatives. But typically we want to find where it's 0, because it's between positive and a negative value, and it's continuous and differentiable. There must be a point where the slope is 0, and that's typically what the IVT is for derivatives. And remember that it breaks down as soon as there's a discontinuity, so keep that in mind when you're looking at IVT. So that's the idea of the intermediate value theorem. So again, I'll do a quick recap. It has to be defined on a closed interval of being a continuous function throughout that interval. If that's true, then the function will take on every single value between f of a and f of b. So f of a and f of b, every single value right here. It's going to be every single value. It's going to at least pass it. At least once. It might pass it more than once, but a guarantee is that it's going to pass every single value. And typically we want to see if it's positive and turns into negative, it must cross 0. That's the idea we're going to hold on to. So I have it right here. And we see how it can break down with a discontinuity. And then for derivatives, when we said we're typically looking for 0, this is usually the case for derivatives. If it's positive on one side and then negative on the other end, there must be somewhere in between that it's 0, or the derivative is 0. And that's the idea of the intermediate value theorem. So I'll zoom out if you want to see it all. But that's the idea. It's not a terribly difficult theorem, but it's just hard to get every single, I guess, detail of it fully understood. So it might take some time to understand this theorem, but hopefully it made some sense or even made more sense. And that's it for this video.